Hi folks, Dr. Bolkema here. Hopefully recording a quick video going over activity 2 from class today. That's practicing with the definition derivative. Whoa, what am I saying? The limit definition of the derivative to write down a derivative function for the 6 examples right here. Ta-da! All right, folks, we will start at the very beginning to the extent that is possible. For the first 2 examples, we're going to think about the given function and its slope. All right, so number 1, f of x is the function 1. Right, let's graph this thing. These are x and y axes, and this function is just a horizontal line. Y equals 1. Now, what is the slope of a horizontal line? Oh, sorry, I forgot about that whole video thing. It's going to be great. The slope of this line is 0. No slope at all. So, f prime of x must be 0. Now you can also verify this with the definition, the limit definition, but if we can think graphically, so much the better. All right, number 2, g of t equals t. Well, if we're gonna graph that, right, if we're gonna figure out what the behavior of this function is, that just looks like the line y equals x, right? The input is the output, there's no change, right? What is the rate of change then as we think about the slope at any given point, the change in output versus the change in input, right? G prime of t is going to be equal to 1. It's a linear function, constant rate of change, and that rate of change, that slope, is 1. Nice. All right, moving forward, I'm attempting to record video of my face again. Do I know what I'm doing? Not really. Well, I mean, I know how to take derivatives, but all right. For the latter 4, we are going to, we are going to use the limit definition of the derivative. All right, so turning on our reminder brains, right? That means f prime of x is equal to the limit as h goes to 0, f of x plus h minus f of x all over h. Is it adding anything to have my face on here? It's not clear. Okay. All right. Maybe some entertainment value. I'm okay with that. So example 3, we're looking at the function p of z is equal to z squared. So p prime of z is equal to the limit as h goes to 0 of p, oh dear, let's not write all of this out. I'm gonna run out of space real quick. All right, so z plus h squared minus z squared all over h. Does that seem correct? So that's our z plus h being plugged into our formula. That's just z being plugged into our formula all over h. All right. Now it's time to simplify as much as we can. So we're taking the limit as h goes to 0 of z squared plus 2zh plus h squared minus z squared over h. That's the limit as h goes to 0 of, oh boy, what can we simplify? Well, I see a z squared and a z squared. So it looks like what's left over here is 2zh plus h squared all over h. That's the limit as h goes to 0 of factor out an h, 2z, sorry, that's a 2, not a z, looks better, plus h over h. And again, yes, simplifying time. So we're looking at the limit as h goes to 0 of 2z plus h, which is 2z, right? That h goes to 0, 2z, there's no h in there. H has nothing to do with the 2z. So, yeah, there we go. We've done it. I would report here that our final answer is p prime of z is equal to 2z. There it is. All right, on to the next example. 4 q of s is equal to s cubed. Now I predict this will be a similar process to the previous one. Q prime of s is equal to the limit as h goes to 0 of s plus h, quantity cubed, minus s cubed, all over h. All right, the limit as h goes to 0 of, oh boy, what is s plus h quantity cubed? Let's do it one piece at a time. That's s plus h times s plus h squared. That's s squared plus 2sh plus h squared minus s cubed all over h, which in turn that is the limit as h goes to 0 of, gotta distribute and combine, s cubed plus 2s squared h plus sh squared plus h times s squared plus 2sh squared plus h cubed. Right? What did I just do in that step? Well, I multiplied this s using the distributive property times s squared times 2sh times h squared, and I multiplied this h by s squared and 2sh and h squared. So that should be 6 terms. 1, 2, 3, 4, 5, 6. Excellent. Minus s cubed. Don't forget that last one. All over h. All over accidentally turning on an eraser. All over h. Now, this is the moment of truth where we say, oh look, s cubed plus s cubed minus s cubed, and all our stress melts away when we realize there's an h in everything that's still here. How nice is that? There's an h, and an h, and an h, and an h, and an h. So if we go ahead and do our, if we go ahead and start writing with a highlighter, if we go ahead and simplify, got the limit as h goes to 0 of, we'll factor out that h, 2s squared plus sh plus s squared plus 2sh plus h squared. Did I succeed? Did we actually reduce everything by a single power of h? H is gone, h reduced, h is gone, h reduced. All right, cancel those out, and now we get to take our limit, right? This taking the limit step involves letting each of these h's go to 0, go to 0, go to 0. What is left over? Again, what is left over is 2s squared plus s squared. So at the end of that long process, 3s squared is our result. Q prime of s is equal to 3s squared. Ta-da! All right, 2 more to go. Number 5, we have this function f of t is equal to 1 over t. So as we set up our derivative, f prime of t is equal to the limit as h goes to 0 of 1 over t plus h minus 1 over t all over h. Whoo-wee! Okay, so gut reaction here. The first thing that strikes me is I don't like all of these fractions upon fractions upon fractions. So the first thing I want to do is stop thinking about dividing by h and instead think about multiplying by 1 over h. Okay, so now I'm multiplying by 1 over h, my entire numerator, which looks like 1 over t plus h minus 1 over t. All right, now here's a situation. Our next move here has to be getting common denominators on these two terms we're subtracting so that we can successfully combine them. So let's look at, I'll continue my line over here. We've got the limit as h goes to 0, 1 over h, yes, 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 all very nice. Common denominators, so I'm going to take 1 over t plus h, and I'm going to multiply that term by a dressed up version of 1, which is t over t. I'm going to subtract 1 over t, but I will multiply that by a dressed up version of 1, which is t plus h over t plus h. Okay, maybe it's helpful to think about those in parentheses. A good parenthesis can go a long way. So we are taking the limit as h goes to 0 of 1 over h times, well, the good news is we've made common denominators, right? Our new denominator is t plus h times t. And we can combine all our numerators. That looks like t minus the quantity t plus h. Good news. Did someone say t minus t? Yeah, that cancels. But before I get too excited about cancellation life, we should remember that this negative should get distributed, right? So we are now evaluating the limit as h goes to 0 of 1 over h times negative h over t plus h times t. All right, now is probably the real time for celebrating and saying, ah yes, there's an h and an h, and now I am free, finally, free of h in the denominator, which means I can evaluate this limit, let this h over here go to 0. What do I have? What do I have but negative 1 in the numerator and t plus 0 times t, right? In the denominator, that is negative 1 over t squared. All right, so there's our joyous final answer, right? This function was f, capital F prime of t is equal to negative 1 over t squared. Hooray! Last but assuredly not least, let's look at problem 6. G of y is equal to the square root of y. We'll set up g prime of y is equal to the limit as h goes to 0 of the square root of y plus h minus the square root of y all over h. All right, are you chanting the definition of the derivatives in your head on repeat yet? Fear not, that day will come. All right, what is our strategy when we see things under square roots, when we see radicals being subtracted like this? We're going to multiply by the conjugate. So we're going to multiply by the square root of y plus h plus the square root of y. And of course, really we're only allowed to multiply by 1 if we're not, being wild and crazy and changing our problem willy-nilly. So we'll we'll multiply by the square root of y plus h plus y over the square root of h plus the square root of y. Okay. All right. And now let us multiply. The limit as h goes to 0 of, let's do the first term. That's the quantity y plus h minus the, let's do the middle term. I'll just go ahead and write all of this out. Usually I've been sort of shortcutting this, but that middle term is the square root of y times the square root of y plus h. All right. After that, oh, I guess I'm not foiling, am I? I'm fioling. First inside, outside, last. Anyway. Let's see. It's going to be plus my outside terms multiplied together gives me a square root of y times the square root of y plus h. And then at long last, I will take my final terms. I've really committed to using different colors here, and now I'm struggling. Oh well. This final term is the product of square root of y times the square root of y, so that's minus y, just y on its own, right? Because secretly, that's the square root of y times the square root of y. It's the square root of y squared, which is just y. Yay! Okay. Sometimes it's nice to just show all the work. All right. Whew, all of that is over h times the square root of y plus h plus the square root of y. We're gonna do our best to not lose any of these details. Okay, so good news, right? What is the point of multiplying by the conjugate? This negative version of this positive item here, these all just cancel. The middle terms cancel. And what we are dealing with is the limit as h approaches 0 of y plus h minus y over h times the square root of y plus h plus the square root of y. Okay, so if you like doing all of these, all that multiplying out with the conjugate kind of in your head, it is totally reasonable to skip that middle line at the moment and just jump to this point, as long as you know you can justify every step. All right, so that's the limit as h goes to 0 of h over h times the square root of y plus h plus the square root of y. Make that a little longer. We celebrate. H and h can cancel, and we can let h go to 0. We can evaluate that limit at long last. So what do we have here but the limit? Oh, no. I just said I could evaluate the limit. What we have is 1 over the square root of y plus the square root of y, right? That first one is secretly the square root of y plus 0. We have 1 over 2 square root y. Okay, what a journey that was. G prime of y is equal to 1 over 2 square root y. All right, y'all. I hope that was at least marginally helpful. Please let me know if you've got questions or, yeah, if you have anything else you'd like to see. Thanks.